Yeah, so today we'll talk about a binary to decimal conversion. Binary to decimal conversion. Okay, so given a binary number, say for example 1, 1, 0, 1. Okay, so this is the binary number given. You need to find out its equivalent decimal number. It's equivalent decimal number. Okay, so mathematically, how we get equivalent decimal number? By multiplying each digit with the powers of 2, starting with 2 power 0, then 2 power 1, then 2 power 2, then 2 power 3. Okay, so how we get the number? First digit 1 multiplied by 2 power of 3 plus 1 multiplied by 2 power of 2 plus 0 multiplied by 2 power of 1 plus 1 multiplied by 2 power of 0. Okay, so if you see this 2 power of 3 is 8 ones are 8. Okay, so plus, and this is 2 power of 2 is 4 plus this will be 0, then plus this is 2 power 0 is 1, 1 multiplied by 1 is 1. Okay, so then 8 plus 4 is 12, 12 plus 1 is 13. Okay, so then equivalent decimal number is 13 base 10. This is how mathematically we'll get equivalent decimal number for the given binary number. Okay, so the same kind of calculation now your program has to perform. You have to write a program such that your program performs the same kind of mathematical operation. Right? So we'll write the program straight away. We'll go into the program. Just wait. Right. Otherwise, what I do is I'll directly go to online compiler. Online C compiler use Yes, am I audible actually? Is my voice clear? No response. Okay, right. So we'll write the program. Yeah. So here, I start the program. Program convert binary to decimal. Okay, right. Binary to decimal. Okay. So then include the header file. Yeah, you can start writing along with me. Okay, get ready with your textbooks. Okay, so you can practice writing program. Leave one space for a function prototype. Okay, so then begin main. Write the main function. Okay, then begin the main function. So here you need to enter binary number. Okay, so you declare a binary number. Okay, so you can declare long type so that you can enter a long binary number. Say long bn. Bn is binary number, and dn is equivalent to decimal number, you can say. Okay, right? So you can ask the user to enter a binary number. Enter a binary number. Binary number. Actually, this statement you should not write in a online coding tests. Okay, so by default it takes input. So that's why without this printf you have to write only this scanf, assuming that the input is available. Okay, so you have to read that input. Already input is entered. Okay, so scanf, say percentage LD, long type we declare now. Then address of where to store in the variable bn. Store the value in the variable bn. Okay, so now bn is our binary number. Okay, so now call the function which converts binary number into decimal and returns that value. Okay, so what we call it as binary to deci. We call it as binary to deci and pass a bn as argument. Bn as an argument. So what it will do? It returns a equivalent to decimal number that you catch in a variable called as a dn. Okay, so this is how you can write the statement. Now dn is equal to binary to deci. Binary to deci, pass bn as argument. Okay, right. So then this function converts binary number into equivalent decimal number and you are getting that number. So directly now you can print that number, say printf, then you say equivalent decimal number, equivalent decimal number equals to percentage LD, then say new line, comma, where is it? dn, in the variable dn. Okay, so that's it. Then say return 0, close. That's it, your main over. Okay, right? So yesterday we discussed that we practice writing the function before the main. Okay, so that we do now, so that we can avoid writing prototype. Okay, so now what we do, we define the function here. Return type is long. What is the function name? Binary to deci. Binary to deci, and argument type is long again. Okay, so long bn, binary value you are getting. Okay, so then here what you need to do, so just see here, given this number, you have to extract one digit. You have to extract each digit and then multiply that with the powers of 2. Okay. So when you extract first the rightmost digit, you will get in the remainder, that you need to multiply with 2 power 0. Next time you will get the next digit 0 you will get. Then you need to multiply it with the 2 power of 1. Then next time in the remainder you will get 1. When you divide this number with 10, you will get next number 1. Okay, multiply. That means you have to increase the powers of 2 every time. When you get remainder, you have to increase the powers of 2 and immediately multiply the remainder with the corresponding power of 2. Okay, so for that purpose, what we required an integer variable reminder we require. Okay, so then what else we require? This is integer type. Okay, so long type, or this also we declare as long. Okay, so that everything is common. Okay, so then we required a decimal number. Okay, initialize it to 0. Initialize it to 0. Okay, so then similarly 2 power 0, 2 power 1, that you can implement by using mathematical function. Okay, or you can also generate. I'll tell you in two ways how you can uh, generate those two powers of 2. Okay, right. Now you got the binary number 1101 you got. Okay, so now what you need to do, finally what happens when you go on divide the number with 10. Okay, so then first you will get 1, next to 0, next to 1, next to 1, and finally your number becomes a 0. Okay, so as usual, as sum of digits and previous programs are there, no? So while n, you can say while bn, this is okay. So while bn, okay, that means while bn not equals to 0, that is the meaning there. Okay, so first get the first digit, remainder is equals to, how can we get the first digit? Bn mod 10. Bn mod 10. Okay, so you got the first digit. What you need to do is you simulate from the mathematical operation to program conversion. Okay, so first digit 1 you got, immediately you multiply with the 2 power of 0. Multiply with the 2 power of 0. Okay, so that 2 power 0, 2 power 1 power you need to store now. So what you can do is you can just declare a variable called as a power and initialize it to 0 initially, because 2 power 0 you need to start. Okay, so what I am doing is I got the first digit, I am immediately multiplying this with the, with the 2 power of 0. So I can call a power function here. Okay, 2 comma, then what is the power here? Variable power. Okay, it is nothing but 2 power 0. Okay, so then the first digit 1 multiplied with the 2 power of 0. Okay, so this, what you need to do, you need to add it to decimal number. Okay, so it is sum of multiplication product of powers of 2. Yes or no? Sum of product of powers of 2, each digit with. Okay, right. So that means you immediately you add it to decimal number. Okay, so you can write like this: decimal number is equals to decimal number plus remainder into multiplied by 2 power of. Okay, so you got the first digit multiplied with 2 power. So then what you need to do, immediately you increase the power plus plus you say, so that your power will become 2 power 0 to 1. Okay, then reduce the number here. So n you reduce, what is n here? Bn. Okay, so bn slash is equals to 10 you say. Bn slash is equals to 10. That's it. Okay, so this loop repeats. Okay, so until bn becomes a 0, and it extracts each digit and multiplies with the 2 powers and add it to decimal numbers. Finally, where is your decimal number? In dn, variable dn. So you return dn, return dn. Okay, so then close the function. That's it. This is your function. This is your function. Okay, so same mathematical calculation we are performing in the program. Okay, so see, I am getting the each digit in remainder, then multiplying that with the power of 2, multiplying with the power of 2. Okay, then I am storing that in the decimal number, each digit multiplied with 2 power and adding to decimal number. Then I am incrementing the power and I am reducing the number to remaining digits. Okay, so like this continues and it returns 0. That's it. Your program is over. Okay, so let us see execution of this. Is it okay? Are there any doubts? Have you finished? So no need of any here what prototypes, no? So that's why you can just remove that white space in between. Okay, so I'm just copying this. I'll copy this in online compiler. So online C compiler. Okay, right? So remove everything and copy paste your program here. Okay, so this is our program, right? Now let us run the code. Yeah, there is some error it seems. So power function.
Sir,
So power
excuse
function
me,
has
sir.
included
Excuse me,
math.h.
sir.
Similarly, there is expected identifier. Okay, so wait, 27 line of that. Right. So first let us include the math.h function. Even though we don't include math.h, okay, so math.h, okay, so it works. It includes sometimes. Okay, so line number 27, yeah, extra. I think this is extra. Okay, right. Let me run the code again. Yes, now it is asking enter a binary number 1101. I enter. Okay, so equivalent decimal number equals to 13. It has displayed. Just see here. Okay, so we solved this mathematically and we got the same 13 here. Okay, right. Sagar, why you are calling screen not visible? Huh? Okay. One sec. Share screen option. Yeah, hope it is clear now. Okay, right. So, yes, yes. Okay, right. So just see here what we did. What we did is here we declared a binary number bn variable and dn is equivalent to decimal number. So we are asking the user to enter a binary number. Okay, he enters and then we are catching in the variable called as bn. Okay, then we are calling the function. Okay, so this function we are calling here, which converts binary number to decimal and returns that we are catching in variable dn, and I am printing equivalent decimal number, equivalent decimal number, and that is stored in dn. It prints the equivalent decimal number. So how it converts? Now the function definition, if we see the function definition, now bn is the binary number. So each digit you have to extract. For that, we have to get the remainder. Okay, so then initially say the decimal number is equal to 0 and powers you need to generate from 0 onwards. So that's why declare a variable power is equal to 0 here. Okay, so while bn, this you know already, bn and finally becomes 0 now. So as long as bn is not equal to 0, you repeat this. So first I am extracting the first digit, then I am multiplying this with the power of 0, then I am incrementing the power, then I am reducing the number to remaining digits. Okay, so this loop repeats and finally you will get decimal, equivalent decimal number. I am returning that. Okay, so that will be returned to main function, and where it will be stored? It will be stored in a variable called as dn here, that it prints. Okay, so this is the program, and let me execute the program here once again. Okay, so that now equivalent binary number, say for example 4 once, if I enter equivalent by decimal number is 15. 4 once means 15. Okay, so direct mathematical calculations we converted into programming steps. Okay, so whenever they are repeated operation, then use a loop here, while loop or for loop, anything you can use there. Okay, any doubts? Any doubts? So I have given participants, you can unmute yourself. If you have any doubts, you can unmute. and you can speak.